little larger problem. 14x to the 6th minus 35x to the 3rd minus 7x squared. X to the 6th, x to the 3rd, x squared. So that looks like it's in descending order. Let's try to find the GCF. 7 goes into all three numbers. And then the most x's that they have in common is x squared. That's right. So 7x squared. What's left in the parentheses? 2x to the 4th. 5x minus 1. So don't forget that minus 1. You got to have that representative for each of those. Now, we won't do x method on this one because it's x to the 4th and then plain x. That one, you can't do the x method on that. It's either got to be x squared and x, or x to the 4th and x squared, x to the 6th and x cubed. That's the only way the x method works. It doesn't work on one like this. Okay, so that's why we won't take that further. Let's do this one. 8x squared plus 3x to the 4th minus 5x. What's wrong with that one? Not in descending order. Okay. What you got to go first? 3x to the 4th plus 8x squared minus 5x. He was in the right spot. Everybody else was in the wrong spot. Now, GCF. Just an x, no number? No. Okay. What's that leave in parentheses? Good job. And again, we couldn't do x method on that what's left there because it had x cubed and plain x. It needs to have x squared and plain x if we're going to use x method to do that. So we won't go further from that. All right, so GCF, easy thing. You always have to look for a GCF first. Okay, if you try to do x method or difference of squares and you don't do the GCF, you're going to end up having larger numbers than you should, and also not the fully factored form of a polynomial. So make sure you look for a GCF first. Let's look at the x method. So x squared plus 14x plus 45. And then I'm going to write out over here ax squared plus bx plus c so that we can explain the x method. How many of you have never seen x method? Anybody? You had? Or you don't remember it, maybe. That may be the case, okay? X method is super easy. It's just a way of organizing your thoughts for factoring. When I was coming through high school, we learned factoring by guessing and checking, which X method is kind of a way of guessing it, but there's a little bit more strategy to it. So the way you set up your X, just make a big X. On the top, you're going to multiply a times c, and a is always the number that's in front of x squared. So a is always in front of x squared. C is always the constant that's on the end. Okay, so for our problem, what's a? 1. So we're going to say 1 times 45, and the 45 is going to go up top, to the top part of the x. In the bottom, it's always going to be b, which b is always in front of plain x. So b for us would be 14. All right. And then we need to fill in the sides. The side numbers need to multiply to be equal to a times c and add to equal b. All right, so we need two numbers that multiply to be 45 and add to be 14. Well, 9 times 5, that's the right two numbers. Okay, now for most quadratics, what you will then do is replace the middle term with those two. Okay? I'm just replacing 14x with a 9x and a 5x because that's the same thing, right? Because if I simplified this red line, it would be the same as that one, right? So we're making a trick happen here. It's not really a trick, it's a mathematical process. Now, the next thing to do is say, okay, how many terms does this red line have? It's got 4 now. And what method do we use when there are 4 terms? Grouping. And grouping takes the first 2 together and the last 2 together. And then we go back to doing GCF again. Okay? What's the GCF of the first 2? X. And then what would be left in the parentheses there? X plus 9. What's the GCF of the second pair? What kind of 5? It's a positive 5, so it's plus 5. Don't leave that sign out. Most people miss this stuff because they'll forget to put that sign there. They'll get in a hurry. And they'll think, oh, I don't need it. Yeah, you do. You need it. Okay? So plus 5. What's that leave in the parentheses there? X plus 9. Notice that those parentheses match. That's important. If they don't match, something's wrong. Either the polynomial doesn't factor or you pulled out the wrong GCF. All right, your factors are x plus 5 and x plus 9. It doesn't matter if you put the x plus 9 in the front and the x plus 5 in the back. It doesn't matter. Either way is fine. Okay? Now, I will tell you that there is a shortcut when there's a 1 in front of x squared. You guys probably, if you're remembering factoring from Algebra 1, you know that if there's a 1 in front of x squared, once you get the x set up, you can go straight to your factors. Because here we got x plus 5. That's a positive 5 over there, isn't it? That's a positive 9, so that's x plus 9. If they were negatives over there, you'd have a minus sign in the middle of the factor. But that only works if there's a 1 in front of x squared. Got to have that 1 there to be able to do that. If there's anything else there, it doesn't work that way. Okay? Try this one. 2x squared minus 15x plus 18. Let's factor that. So we look first to see if it's in descending order. X squared, plain x, no x, that's in the right order. Then we look for a GCF across the whole problem. 2 and 18 have something in common, but the 15 messes that up. 15 and 18 have something in common, but the 2 messes that up. So no GCF. Since there's not a GCF, then I can take that and just do what method? X method. So what goes on top of the x? 18 times 2 is 36. What goes on the bottom? Negative 15. B is negative 15 for us. Okay? Now we need to fill in the sides. We need 2 numbers that multiply to be a positive 36 and add to be a negative 15. Very good. Negative 12 and negative 3. Can I take the shortcut on this one? No, because it's got the 2 in the front. So I have to do the grouping step. Okay? So I'm taking 2x squared. Then it does not matter which one of those, the negative 12 or the negative 3 you put next. Your choice. I'm going to put the negative 12 first because I know the GCF between 12 and 2, right? That's what I'm thinking. And then minus 3x plus 18. But your in-between steps, if you put the minus 3x first, your in-between step will look different, but your final answer should be the same. Okay? All right, now, once I put those in there, what do? Group. First 2 together, last 2 together. What's the GCF of the first group? 2x. What's that leave in parentheses? Good job. What's the GCF of the second group? A minus 3. We're always going to take that sign that's right there. We're going to take it out with it. Okay, so if it's a minus sign in the middle right there, it's going to be a minus sign when you pull out the GCF. So we're going to pull out a negative 3. And what's that leave in the parentheses? It's going to be x minus 6 because negative 3 times x is negative 3x. Negative 3 times Negative 6 gets me the positive 18. So that's how that sign changes there. And then what are your final factors? 2x minus 3, x minus 6. Boom. You factored quadratic. Easy stuff. See if you can do this one. Just x squared minus 15x plus 26. See if you can set that one up and get it back. All right. What's our x look like? 26 on top, negative 15 on the bottom. So we got a negative on the bottom and a positive on the top. So we know both numbers need to be what, Barry? Negative what? Negative 13, negative 2. Good job. And can we take the shortcut? Yes. And I want you to take that shortcut. At this point in your Algebra 2 world, you need to get faster at doing some things. And when there are shortcuts available, let's take them. So this is x minus 13, x minus 2, and you're done. Okay. You still need to do the grouping in between to make it make sense to you. That's fine. But at some point, anytime there's a 1 in front of x squared, you want to start working yourself toward that shortcut because it's worth it. Saves you, a few seconds problem. The point is to get it into what's called intercept form. And then we can find where the graph of that crosses the x-axis by the factors. And then we can also take larger polynomials and break them down into pieces that some of the pieces are quadratics, and you can solve those. And when we do the application parts of this, you'll start making some sense, because when we do quadratics, projectile motion is a good example of quadratics. That when you shoot anything, or like good examples like throwing a football season. When you throw that football, even when you throw a short pass, it's on a line, but it still has a little bit of a hump to it. You throw a really long pass, it definitely has that arc to it. That shape that it follows is kind of a quadratic equation that it follows there. And then we can find time it's in the air. We can find how high it got, all that stuff. If you ever watch, they really do a lot of it now on ESPN, the analytics of the game, and they're like home run derby. They track the ball and all that. It's a quadratic kind of shape. It's in a three-dimensional sense, so it's a little bit more complicated. But it's the basic idea is an equation that it follows, and that's how they can figure the distance that thing flew without, somebody out there. Oh, it hit seat number 253, and we know that one's how many feet from home plate. That idea, but it's an equation that they figured it from instead. Let's do this one. 5x squared plus 22x minus 48. As you get into higher level math, a lot more of it applies to everyday stuff. The easy stuff doesn't apply so much to everyday things, quite as much. But the higher level math you get to, the more stuff you can really relate it to. All right, so what we do? X method, GCF. Is there one? No. 5 and 48 don't have anything in common. 22 and 48 do, but that doesn't help us. So what goes on the top? Negative 240. Oh, that's a big number. Slightly large. 22 goes on the bottom. So we need numbers that multiply to be a negative and add to be a positive. So what do we know about them? One's got to be bigger than the other. One's positive, one's negative. Which one needs to be the positive one? The bigger one or the smaller number? The larger number. Okay, so context clues about what kind of numbers we're looking for. So does anybody have those numbers? 30 and negative 8. That's good. Now, how'd you get to those numbers, Will? That's right. Kind of help us think through that. Those that didn't get those right off the bat. you started trying things, right? Yeah, you started trying numbers that I know go into 240 and breaking it down and trying something and seeing if it would add up to be 22. Okay. Somebody first block said, oh, well, it starts with 24, so I knew, things that go into 24, so it should go into 240. So they, he guessed an 8 first. And stumbled into the 30 wrong on the first try. If you don't get it on the first try, don't give up. Keep trying other numbers to make that work, because most of the ones you're going to see today will factor. But there are some that don't, but you've got to go through all of the list to make sure. All right, can we take a shortcut? Oh, man. So 5x squared. Which one do you want to put first, the 30 or the 8? 30. Who's ever got their phone out doing Khan Academy? Put it up. That's a Khan Academy tone. I'm not dumb. You're not supposed to have your phone out anyway. Because if that's going to be a problem, I will start looking for it and sending your butts to the office. I am not going to put up with it. I'm tired of having to tell people to put your phone up. Not my college class. I can't tell you to leave like I can up there, but I can send you to the office and let them deal with it. They get enough of them, they'll get tired of it too. Now, what we do next? Group. 5x, x plus 6, negative 8, x plus 6. Final answer, x plus 6, and 5x minus 8. Again, it doesn't matter what order you put those in. If you put the 5x minus 8 first, that's fine. But you got to have both of them there. Okay. Number 9. 2k squared minus 16k minus 40. Common factor of 2. So pull that out first. Does it just go away? No. Now what do we do? Right, we do the x method on this because it's got k squared and a k, so we know we can do x method or try it for that. What goes on the top of the x this time? Negative 20, and then negative 8 on the bottom. What does that? Negative 10 and a negative 2. Should be a positive 2, right? Because we got to multiply to be negative 20, so we got to have a positive and a negative, and then it's got to add to be negative. So the bigger number's got to be negative there. Can I take the shortcut on that part? What's in front of k squared now? A 1. So yeah, the parentheses part's kind of a separate problem, and there's a 1 in front of that. So I can take the shortcut to do k minus 10 and k plus 2. And then this 2 that we factored out at the beginning, just out there in the front. So here we're doing more than one method here of factoring. You got the GCF and then you got X method. So you've got to, speed yourself up a little bit. So the shortcut, that's, things like that are where it's going to come in handy. Okay. 9x squared minus 25. Uh-oh. That doesn't look like the runs we've been doing. Why is it a difference of squares? It's 2 terms and have what in the middle? Subtraction symbol, a minus sign in the middle. So that's how we know to even try difference of squares. Okay? We still look for a GCF. Do 9 and 25 have anything common? No. Difference of squares, the reason it's called that is because if it is a difference of squares, you can write it as something squared minus something else squared. What squared would give me 9x squared? 3x. What squared gets me 25? 5. Now here's the beautiful thing about the difference of squares. If you can rewrite it like this, the factors have a 3x in the front, a 5 in the back. One's a plus, one's a minus, and you're done. That's the beautiful thing about differences of squares. That if you can rewrite it as two square things subtracted, then you can factor it really quickly like that. Or if you can think this blue step, I'm fine with that. I hope you can think that blue step because you're writing it down there, so surely it's gone through the brain at some point. Let's do x squared minus 4, something real simple, but the same idea. Two terms with a minus sign in the middle. X squared minus 2 squared, right? So my factors are x plus 2, x minus 2. That's it. Differences of squares should be the fast ones that we get real fast. Maybe we got 16x squared minus 1. So we're thinking this step here. What squared is 16x squared? 4x. What squared is 1? 1. 1 is a square number because 1 times 1 is 1. Okay, so what are our factors? Yeah, 4x plus 1, 4x minus 1. What if we had 16x squared minus 18? Well, 16 works with the difference of squares, but 18 doesn't. But what do they have? Of 2, so that leaves us 8x squared minus 9. Is that a difference of squares? Why not? 8's not a square number, right? 9 is, but 8's not. So I can't rewrite that as a difference of squares. So I'm done with that one, right? So GCF is all that we can do with that one. So you got to be able to recognize when is something a difference of squares and when is it not, and be able to go from there. Let's look at 18x squared minus 24x plus 8. I'm just going to mix it all together here. What do we do with this one? Which is 18, 24, and 8. 2 goes into all those. Is that right? Right, 18, sorry. So 2, and then that leaves 9x squared minus 12x plus 4, right? What do we do with that stuff in parentheses? X method, all right. So what goes on top? 36. We need it to add to be negative 12. Negative 6 and negative 6, I heard. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So that's the right two numbers. The 2 we started with, I'm just putting outside of a bracket there. And then I'm writing 9x squared minus 6x minus 6x plus 4. Because I got to do some grouping now because I couldn't take the shortcut because it had something the size of 1 in front of x squared. GCF of the first group. 3x. 3x minus 2 is left. What do we pull out of the second group? Negative 2. Leaves the 3x minus 2. The 2 that we pulled out at the beginning still out there. So, final answer. Yeah, you could write it that way. So this is one way to write it, or you could write it 2 times 3x minus 2 squared like that. And that's both of those are the same answer. I'd take either one. Absolutely perfect. Okay. Pretty easy there, right? Not too bad. Let's do this one and one more. M squared, n squared, minus 49. Do that one. The two variables can sometimes screw us up a little bit. Make sure we're getting that knocked out. What do?
So would that be 3 terms?
No. Terms are separated by addition or subtraction. Well, okay. So you're saying rewrite it like this or think about it like that. What goes in the first parentheses you said? Mn, good. Because what squared gives me m squared? M. What squared gives me n squared? N. And then what goes in the other parentheses? 7. So that gets us our factors. Mn plus 7, Mn minus 7. If you put the minus first, that's okay. It doesn't matter. Pretty easy there. Let's go to the heavy lifting step. X cubed plus 8x squared minus 25x minus 200. Okay, why grouping? Because there's 4 terms, 4 pieces there. There's not a GCF across all 4 terms, so we're going to go ahead and go to the grouping step. What's the GCF of the first group? X squared. What's that leave in the parentheses? X plus 8. What's the GCF of the second? Negative 25. What's that leave in the parentheses? X plus 8, because 8 quarters is $2, right? What are our factors now? Ooh, x squared minus 25 and x plus 8. Is that done? Why not? The first one can go farther. We can factor that a little bit further. It's a what? Difference of squares, right? What are the factors for that without doing the step in between? Yeah, x minus 5, x plus 5. What about our x plus 8? Still there, right? Hasn't gone anywhere. So we factored, that's a higher degree polynomial. We ain't there yet, but that's where we're headed. Okay? So we were able to take a much larger polynomial using the same factoring skills that we already know and break it down. So that's where we're headed. We're going to get to problems that are a little tougher than that one. But the same idea, you've got the skill set. You just want to make sure you're refreshed on it today and Monday. We want to make sure you're refreshed on your factoring. And then we'll get into actually solving some quadratics and doing all of the extra stuff we do with quadratics and that stuff. So